Dear students of economics, welcome to this teaching module titled Presentation of Data. Well, this is the second part of the topic that we are doing at the moment. What we have covered so far in presentation of data is tabulation, the essentials of a good table, the format of a good table, and the various parts of the table. Then we went on to learn about geometric diagrams, and in that we covered just one type of geometric diagrams, that would be simple bar diagrams. Now let's move on. In this lecture, we will study about the multiple bar diagram, the component bar diagram, and construction of pie charts or pie diagrams. Alright then, let's begin. Let us begin with the second type of geometric diagram, which is the multiple bar diagram. Now, a multiple bar diagram is used for comparing two or more variables. Multiple bars are used to represent different frequencies of the data at hand. For example, in this particular diagram, we have multiple bars to represent the COVID tallies that are highest relative to population. Countries with most confirmed COVID-19 cases per 1 million population. In various countries, Belgium, Israel, Czech Republic, Panama, Kuwait, United States, Peru, Chile, Argentina, Spain, and so on. So you have a bar represented for each country, and you have the various frequencies as well as the total number of cases of COVID in these countries are mentioned. Now, what I'd like to do is take a table where we have the number of boys and girls in a computer institute from 2015 to 16. So here it is. Now, how do we represent this data in the form of a multiple bar diagram? What we do is we represent the years on the x-axis and the number of students on the y-axis. We don't need to put separately number of boys and number of girls, because here in the legend we are mentioning the color code, and we are saying here that the lighter colored bars will stand for number of boys and the darker colored bars would stand for the number of girls. And so we plot the number of boys for the year 2015. We mark it against the y-axis. And then the number of girls in that year, which is 12. And so we do the same. 23 and 18 are plotted here for the year 2016. For the year 2017, 25 and 24 are plotted in the next two bars, which shows the number of boys and then the number of girls. So on and so forth for the years 2018 and 19. I'd like to remind you again, get in the habit of plotting your x and your y-axis. Once you label them, then the diagram will mean sense. Here we have taken a table which shows the income in lakhs of 3 departments of a particular firm for various years, beginning from 2015 right up to 2018. And so we have 3 departments, one for construction, one for consultancy, and the other for dealership. So we show the 3 in various color codes, or you could use different patterns or shades. And we have mentioned here the various color codes for construction, consultancy, and dealership. And we use 3 different bars for each of the departments in that particular year. So for the year 2015, you have 30, 15, and 20. So here you go. This is for construction, 30, 15 for consultancy, and 20 for dealership. You could specify the frequency of each department on the top part of the bar. The bars may or may not touch each other. The width of the bar is irrelevant in the case of simple and multiple bar diagrams. And here we have another example of how we can represent a table with the help of a multiple bar diagram. What we have here is the distribution of boys and girls in 3 different streams. And so we have taken the gender on the x-axis. So you have a category for boys and one for girls. And you have 3 bars to represent the arts, commerce and science streams. So you have the number of students basically plotted on the y-axis. And so there is another way you could represent this table, and that would be to represent this three streams on the x-axis and have two bars, one for boys and one for girls. So here you would have arts, commerce and science, and two bars, one to represent boys and the other to represent girls. That's another way you could draw these multiple bar diagrams. And now let's move on to the next type of bar diagram, which is the component bar diagram, also known as the subdivided bar diagram. Now the subdivided bar diagram shows the bar and its subdivisions in two or more component parts. So you see here, this is something that's been taken from real life, where they're talking about the most used resource for overseas trip planning. This was taken in 2017 and for various age groups. So where do they get all their information from? Some get it from travel websites or blogs, some may get it from social media, some from travel agents or tour guides, some from print publications like magazines and newspapers. So all that has been shown in the form of a component or subdivided bar diagram. The total population is represented by a single bar, and its component parts are shown by proportionate parts of the same bar. The different parts of the same bar are shaded differently to represent different variables. Let's see how we are to draw the component bar diagram. Now you have this data, the number of boys and girls in an institute for various years. What we have to do is we have to have another column, and that would be a column for the total number of students. So the number of boys plus the number of girls in the year 2015 would be 32. Now listen very carefully. What we do is we plot the value 32 for the entire bar. So if I could have written the number 32 right on top of the bar, and that would be me plotting this particular frequency. Now how do I divide this bar representing all the 32 students in such a way that I show the number of boys and the number of girls in the same bar? So what I do is I look at the number of boys and I put a bar, I divide the bar at that point on the y-axis, which shows me the value 20. So once I do that, then I know that this part would represent boys as it is shown in the legend here. And so the remaining would be obviously the number of girls. So also for the year 2016, I plot the value 41 to give me the entire length of the bar. And then to know the number of boys, I plot the number or the value 23 on the same bar by looking at the y-axis, the level corresponding to the one on the y-axis. So 23 would be here, and that would separate the number of boys. The remaining would be obviously girls. And so we do the same for 2017, 28 and 2019. Here again we have another example of a component bar diagram, but this time you have to divide the bar into three component parts, not two. So how do we do that? First things first, you have a column for the total. So you total up the number of science, commerce and art students to give you the total column. Why do we need that? In order to plot the frequency of the total number of students in all streams. And that's what we do. We plot 92 to give us the length of the entire bar. And then we set out to divide it. How do we do that? First things first, we put a line. We use the frequency of the number of science students in that year and put a line there at 58 corresponding to that value on the y-axis. Then how do we get this part, the number of commerce students? We add 58 to 20. And what do we get? 78. So we put a line at 78 corresponding to that value on the y-axis, which shows us the number of students. Once we do that, we get a space between the number of science students and the other portion of the bar. So this portion in the middle will give us the number of commerce students, and the remaining would obviously be the 14 students that belong to the arts stream. I'll repeat again. For the year 2018, we plot the value 106 here. And then we begin to subdivide it. First, we draw a line at the value of frequency 45. So here it is. Then we add 45 to 30. And how much do we get? 75. And we plot that line there at that point, 75. So this portion in the middle will give us the 30 students of the commerce stream for the year 2018. And the remaining would obviously be the arts stream. We don't have to do anything about that. I'll repeat one more time. We plot the value 93 to give us the length of the entire bar. First, we put a line at the number of students in the science stream at 40. Then we add 40 to 30, which gives us 70. So we put a line at the level of 70 corresponding to the values on the y-axis. So that will give us the number of commerce students, and the remaining would obviously be students of the arts stream. Alright then, now we have an example of yet another component bar diagram wherein you have to divide the bar into 4 component parts. So you have the marks obtained in 4 different subjects in 4 different classes, 7th, 8th, 9th and 10th of a particular student. Now what do we do first? We first derive the column for the total number of marks obtained in each of these standards. And why do we need that? Because we need to plot the lengths of each of these bars, which represent the 4 standards and the marks obtained in these various classes. Once we plot the total values, we get the lengths of the 4 bars, and then we set out to divide it. First, we try to get the number of marks obtained in English. So at 55, we plot a line, we divide the bar at that level. Then we add 55 to 64, we get 119. So we put a line there. Then we add 119 that we obtained here to 78 and we get 197. So we draw a line there. The remaining marks are obtained in the subject of maths. Let's take the second one. We put a line at 58. Then we add 58 to the marks obtained in Hindi and we get 116. So we put a line there at 116. We take 116 and add it to 64 and what we get is 180. So we put a line there at that level. So the remaining portion would give us the marks in maths. In the third bar, we put a line at 62. We add 62 to 57 and we get 119. So we put a line there. Then we add 119 to 81. And when we do that, we get 200. So you put a line there. The remaining are the marks obtained in maths. Let's do the last one. We put a line at 73. We add 73 to 63 and we get 136. So we put a line at the level that corresponds to 136. Then we take 136 and add it to 93. And when we do that, we get 229. So that's somewhere here, corresponding to its value on the y-axis. And then we put a line there. So the remaining marks would be the marks obtained in maths. And that's how we divide a bar into various component parts. Now let's move on to pie diagrams or pie charts as we call them. The method of representing statistical data with the help of sectors of a circle is known as a pie diagram or a pie chart. Now, a pie chart or a pie diagram represents the component parts that go to make up the complete pie as a set of different sized slices, as you can see here. The total of all the given items is equated to 360 degrees. Now, if you look at half of the circle, it's 180. And you have the other half of the circle, which is 180. And when we add both the semicircles, we get the angle, degree of angle of the entire circle, which is 360 degrees. That you know. And the angle representing each item is calculated. Why? Because a circle makes an angle of 360 degrees at the center. Now here we have, most of us have big worries about COVID-19. And so a survey was conducted with US consumers. And there were 79% of females, 64% of the group were over the age of 60. And the question that was asked of them was, what is your greatest worry about COVID-19 and why is that? So these were their answers. Getting sick or dying. So you had 29% answering that one. Then loved one getting sick or dying was a concern of 22% of the people who were surveyed. Financial and money concerns, 13% of the population had these concerns. They had doubts about the country's leadership. That would be 10% of the data that was studied. Some had concerns about the economy, and those were 8% of the population that was studied. 8% had concerns regarding the impact on society, that's shown by this gray area. And the remaining 10% had other reasons or other concerns. So that is how you can represent various aspects of our data or subject of our study with the help of a pie chart. Now suppose you are given the percentage value of an item in a table and you have to convert it to the degree of the angle. We have a formula for that. We take the percentage value of the item divided by 100, obviously, because when you're talking about percentages, it is over 100. And we multiply it with the total angle of the degree of a circle that the circle makes at the center. For example, if you're talking about 25% of the population that is studied, you have 25 upon 100 into 360, and that should give you a value of 90. So that would be the degree of the angle. Yeah, let's see here. The results of the survey on the favorite hobbies of students are shown in the pie chart. What is the measure of the angle of the sector representing swimming? Now the percentage is given, and that is 17%. We need to find the degree of the angle that we need to plot. So you have 17% of 360, in other words. So the measure of the angle is given by 17 upon 100 multiplied by 360. And when we do that, we get 61.2 degrees. So we will keep our protractor at this point and we will plot 61.2 degrees. And that would give us this radius here. Consider that we are studying the expenditure on construction of a house on various items or aspects like labor, bricks, cement, steel, timber, supervision. So the percentage values are given to you. You have to convert it to degree. And how do you do that? Again, 25 upon 100 into 360 will give us 90 degrees. 15 upon 100 into 360 will give us 54 degrees. 20 upon 100 into 360 will give us 72 degrees. 15% it's already done, so they get the same value, 54 here as well in the case of the supervisor or supervision. And where timber is concerned, 10 upon 100 into 360 will give us 36 degrees. And so these degrees are used to divide the entire circle into various sectors. Let us look at the steps now that we need to use to draw the parts of the pie chart or to divide the entire circle into its various slices or sectors. First things first, you need to draw the circle with the help of a compass. Go to the center and take your scale and draw the first radius. So that would be your first step. the next step would be to place your protractor like this. So the degree of the angle for the sector that represents cement is 72 degrees. You need to plot that. And then you have to draw a line to give us the sector that represents cement. That would be your first sector. The next step would be to place your protractor at the new radius. See, you have a new radius here, and that is where we place our protractor. And the degree of the angle for bricks is 54 degrees. So we look at 54 degrees, and we'll have to draw another radius at that level. So let's draw that there. So once you have the new radius, you know that that area or that sector represents bricks. Subsequently, you will have to place your protractor again at this level where you have the new radius, and keep on plotting the degree of your angle till you reach the last sector, where you don't need to plot because the last sector is the remainder that is left, which is 90 degrees of labor. I hope you got that. So let's move on to the next part. Now what I want you to do is some of these exercises where you have to draw pie charts for the data that is given in the slides. First, you have to find the degree of the angles, and for that I've given you your formula, which is the percentage, that is 30 upon 100 into 360 multiplied by the degree of the angle. So you have to fill up the degree of the angle and then follow the instructions that were given previously. Take a compass, draw your circle, draw the radius, place your protractor, plot the angle, draw a new radius, place your protractor at the level of the new radius, and so on. Here I want you to look at yet another aspect that is involved in the construction of pie charts. Now, what I gave you was a formula to convert percentages into degrees of the angle, like I've shown in this table. And I want you to draw a pie chart for this table as well. So it tells us the percentage of students getting first class, second class, third class failed. Yeah, so 100% of your data is represented on 360 degrees of the angle of the circle that the circle makes at the center. Now consider that you are not given percentages. So you have the actual figures of expenses on food, house rent, clothing, education, savings, and other expenditures. What you have to do in that case is total up all the expenses. So you get the value 12,000. Now how do you convert this to the degrees of the angle? Very simple. You take 4,800, divide it by the total, that is 12,000, and multiply it by 360 degrees. And you get 144 degrees of the angle. For each of the tables that I gave you to draw pie charts, I want you to draw neat and labeled pie diagrams. And to sum up with, we have learnt about multiple bar diagrams, component bar diagrams, and pie charts. Please see that you do all your work, complete all your work, draw your diagrams neatly. As usual, I'd like to end with a quote, and here it is. It's given by someone called David McCandless, and he says, visualizing information can give us a very quick solution to problems. We can get clarity or the answer to a simple problem very quickly. So when you visually look at diagrams, for example, your simple multiple component bar diagrams or even pie charts, you can understand with clarity a particular issue or a problem. And so you can come up with solutions easily. Well, thank you students for giving me a listening ear. I'll leave you right now with this thought. Thank you.